Hi students, welcome to chemistry class. So, in this class we shall discuss about Mendeleef's periodic table of elements. First of all, what is Mendeleef's periodic law? Mendeleef's periodic law states that the physical properties of elements are periodic functions of their atomic weights. That means the physical properties and chemical properties are changing with respect to atomic weights. Periodic function means repeating at regular intervals. So, Dmitry Ivanovich Mendeleev, a Russian chemist, arranged the elements known at that time in a table in a systematic order, in increasing order of their atomic weights. So, he arranged the elements based on their atomic weights. Now, if you see here the Mendeleev's periodic table, here 8 columns were arranged and 7 1 2 3 4 5 6 7 rows are arranged. So we can say that there are 8 groups, vertical columns, they are called as groups. Okay, and horizontal rows 7 are there, they are called as periods. He also left some blank places for appropriate places in the table. He predicted some elements. Mendeleev also predicted some elements. What are the elements he predicted? He predicted the elements eka-boron, scandium, eka-aluminium, gallium, eka-silicon, germanium. Where are these elements? These pink color places are nothing but he don't know. These elements he don't know. They were newly discovered. But these places he has already given in his table. He given these places. Right? So what does it mean? He given that places means he know these elements will be discovered in the future. Right? So this colored box nothing but known to Mendeleev. And this squared box is nothing but Dobereiner's triad. They represent the Dobereiner's triad. Lithium, sodium, potassium, Dobereiner triad. Calcium, strontium, barium, Dobereiner triad. Sulfur, silurium, tellurium, Dobereiner triad. Chlorine, bromine, iodine, Dobereiner triad. So he placed the Dobereiner triad as well as the elements known to Mendeleev he arranged. And he also, these pink color boxes nothing but he predicted the upcoming elements, new elements which are going to be discovered. That elements also he has predicted. Especially he predicted scandium, titan, gallium, germanium. Scandium called as eka-boron, eka-aluminium, gallium, and eka-silicon, germanium. Exactly the chemical properties are matching here. Gallium, aluminium chemical properties, boron, scandium chemical properties are exactly matching. So whatever he predicted is 100% correct. Okay, in that way he was successful. The Mendeleev was successful, and he is treated as a great intelligent scientist because of his prediction. Right? And next, Mendeleef tried to explain the similarities of elements in the same group in terms of their common valency. So here if you see, hydrogen, lithium, sodium, potassium all have the same valency +1. Beryllium, magnesium, calcium, zinc all have the same valency +2. Boron, aluminum, scandium, gallium, yttrium, indium all having a +3 valency, +4 valency, tetravalency, pentavalency, and 6 valence and 7, like that. The valencies are whose elements are having the same valency are placed in the same group. Next, he divided the table into 8 vertical columns called as groups. These are the vertical columns 1, 2, 3, 4, 5, 6, 7 and 8. 8 groups he has divided. This zero group he don't know. He didn't kept this zero group elements because he don't know inert gases. He don't know about inert gases at that time. Next, the horizontal rows in Mendeleef's periodic table are called periods. Elements in a period differ in their properties. He predicted some elements are missing and left blank places at appropriate places in the table. He predicted the properties of these additional elements in advance and named those predicted elements tentatively by adding prefix eka. Eka is a Sanskrit word meaning numeral 1. To the name of element immediately, eka boron, eka aluminum, eka silicon were almost the same as those of scandium, gallium and germanium respectively, which were discovered later. The placement of the elements in the Mendeleef periodic table helped in correcting the atomic masses of some elements like beryllium, indium and gold. So these are the advantages and merits of Dmitry Ivanovich Mendeleef. These are the merits. Now we shall see the demerits, limitations, drawbacks. Okay, so what are the drawbacks? Certain elements of highest atomic weight precede those with lower atomic weight. So this is one drawback. Where is the drawback? See here. If you go from tellurium to iodine, you are going from tellurium to iodine. Tellurium should come next, iodine should come first. So that is a mistake here because it is 127 and it is 128. Everywhere it is increasing, 119 to 122, 112 to 115, 108 to 112. Here the atomic weight is increasing as we move from left to right. But in the case of tellurium to iodine, the atomic weight is decreasing. So this is the demerit of the Mendeleef periodic table. Okay. Next, dissimilar elements are placed together in the same group. For example, chlorine is a 7th A group element and manganese is a 7th B element, but chlorine is a non-metal whereas manganese is a metal. So he placed it in the same group. Okay, see here, where is chlorine? See, chlorine and manganese, he placed it in the same group. He said that he has placed the elements with similarities in the same group, he said, but chlorine and manganese are not having same properties, chemical properties. This is a non-metal, this is a metal, but even though he placed it in the same group, this is one demerit. Okay, thank you my dear students for listening to this class. Thank you.